Hello mathematicians, puzzlers, and other curious people. In this video, we are going to use GeoGebra to decompose and recompose some parallelograms in a way that helps us figure out their area. Let's get started. So here's our first parallelogram. I'm going to use this side right here as its base, which means I need a height that goes straight up from it and probably reaches the other side. Instead of needing to place two helper points to draw that line segment for the height, I'm going to use this as one of them. So I'll place a second point there though. So I'll place one helper point right there, and then I will draw this line segment. That's the height. Now I'm going to take this triangle right here, and I'm going to move it over here. Now this will still show, but we'll be able to see another one. So I need a vector. I think I'm going to move it straight across. I'm not sure how far yet. Now I'm using the Translate by Vector tool. Here's the object I want to translate, and this is the vector, but I see that placement isn't quite right. That's fine. I can just move my endpoint of the vector, and there it lines up. Okay, so my recomposed shape here is a rectangle, and it is 6 units across by 6 units tall, so in fact it's a square. So the area of this parallelogram originally that we started with here must be 36 square units. Here we have another parallelogram, and I'm going to use the exact same technique. So I'll place a helper point right here. I'll draw a line segment right there. That's the height of the parallelogram. I will draw this triangle right here. Set up a vector to translate by. Use the Translate by Vector tool. And then, okay, I see it now. I see the rectangle that this parallelogram can be decomposed and recomposed into, and it is 6 units wide by 3 units tall. That tells me the area of the rectangle, and therefore the parallelogram that's made out of the same pieces is 18 square units. This next parallelogram is a little trickier. So it doesn't have a horizontal side, but we don't need the base of the parallelogram to be a horizontal side. So I'm going to choose for this vertical side right here to be the base. And this time I am going to draw 2 helper points. Right there and right there, directly across from it, so that when I cut across this, that makes a perpendicular segment to the 2 sides it's connected to. Now I'm going to use a very similar technique to what I used before. I will draw on the polygon that I'm decomposing, and I need to think about where I want to recompose it. So I want to line up the slanted sides, so I think I need to move it downward. I know I'll need to move it further than that, but that'll do to get the vector started. And now I want to translate by vector this polygon by this vector, and I'm just going to adjust the endpoint until it lines up. So I see here we now have a rectangle that's 3 units wide by 5 units tall, so that's 15 square units in all. So this parallelogram made out of the same pieces is also 15 square units. This parallelogram is trickier than the others for a few important reasons. One reason is we have a couple of sides that would make a good base because we can easily see that they're both 2 units long, as compared to the slanted sides, which we don't know their height. But those 2 sides are never exactly across from each other, so I'm still going to draw the height on, but I'm going to draw it in a few different places. I'll start with one right there, and I think I will need another right here. Now I'm going to use the Intersect tool to make sure that these vertices of the polygon I deconstruct are perfectly placed. Then I'll use the Polygon tool to draw that polygon. And now I will set up a translation vector. I see here that my translation vector didn't go right on the grid lines, so I'll fix that. That's a good thing to know about how to fix these. And then I will translate by vector this polygon by this vector, adjust the vector until it lines up. So I see that the next polygon I need is going to need to start here, and I think it would go to about here. So I'll draw the height in there also. The most important thing about the height segments is that they're perpendicular to the base segment. I see that this one went a little off the grid line, so I'm going to fix that. Then I will use the intersect tool on those two spots right there to make sure everything lines up very well. I will draw a polygon with these vertices. Always remember to come back to your first vertex when you're drawing a polygon. I will set up a translation vector. I know it'll need to be longer than this. And I will translate this polygon by that vector and adjust the vector until it's right. That came to the same spot, but that's a coincidence. We've got a few different ways we could handle this next part. I'm going to do it in 2 steps. I'm going to draw this polygon right here, set up a translation vector, and then I will translate this polygon by this vector all the way over to there. Okay, I see that this little triangle doesn't quite line up. So the next thing I will do is draw that polygon, set up a translation vector, translate that polygon by that vector, adjust the translation vector, and there we go. So these pieces of the original parallelogram can be decomposed and recomposed into a 2-unit by 6-unit rectangle. And that tells me that the area of the rectangle and the parallelogram made out of the same pieces is 12 square units. Now that was tricky. And this starts to show why we might want a more numerical method. Okay, last but not least, we have this parallelogram right here. It's already got its height drawn on, so I'm going to use that to help me make a decision about what to decompose. So I noticed the height is a good place to decompose these. I'm going to use the same technique I've been using with a translation vector and using the translation tool to translate that new polygon, in this case a triangle, to the other side. And I notice that now what we have is a 6-column by 4-row rectangle of grid squares. So certainly that's 24 square units. So the original polygon was also 24 square units. If you're really paying attention, you might have noticed that the height of the parallelogram ends up being one of the 2 dimensions of the rectangle. That's a clue to a more numerical way you can work these problems. And that more numerical way you can work these problems would have been a lot easier than what we did here. So pretty soon you'll be working with that more numerical method more often. Calculator!